Perhaps the most difficult challenge in creating ADAS technology is the step in which sensor inputs are used to build a model of the outside world. Traditional computational techniques to do things such as deciding which part of a camera image corresponds to a person have struggled for decades and only become practical recently with availability of significant computing power in the form of GPU-based processing. That processing power has enabled the use of machine learning and in particular deep neural networks to do classification. This graphic sketches out how that works. The idea is that a huge number of examples of things, in this case faces, which some human has labeled as this is a face, here's where it is in the picture, are used with a deep neural network structure. You can see multiple layers with interconnections to train that system to detect what faces are. It does this, in this case, with a convolutional neural network, which does feature extraction and then builds up at each layer to more and more things that look like face. And finally, at the output says, this is a face or this is not a face. The key idea here is that rather than a human programmer instructing the computer on what a face is, instead, this neural network structure is trained based on huge numbers of examples to statistically figure out what things are faces and what are not. The good news is that this enables us, for the first time, to, with pretty good reliability, be able to say, yes, that's a person, that's a stop sign, that's a car, and so on. The bad news is that this is a statistical approach, and it may struggle to get better than something like 99% accuracy. That's great for IT applications where 99% is fantastic. It struggles when you get into life-critical system safety, which needs much, much higher reliability than that. A particular challenge is being able to prove that this type of computational approach is actually as good as you need it to be.